Hello, hello. Hopefully everything is working properly. Uh, so today will be a somewhat slow stream, perhaps segmented over several hours. I am semi-hungover, therefore things will be rather slow today. Um, so, uh, we're gonna do some math stuff today, which will probably be boring for some. Math is not an entirely strong suit of mine, especially not um, remembering the underlying rules, and therefore I won't be explaining too much. Uh, there are several great math libraries. Uh, we could use those, but uh, in general, I would like a framework that is tailored to our needs, and therefore we will be building some of these structures ourselves, which gives us some degree of control over optimizations and memory layout and so forth. If we run into too many problems, we might abandon it and just use the DirectX math library. Um, but yeah, at least for now, we will be using a self-made math library. Um, in terms of the whole series, we need to um, do some matrix um, math. It's because to be able to transform, let's see, if we say we have a coordinate system, I'm really not used to paint being this way. I'm from the olden days where paint behaved properly. Uh, let's see, if we have a world coordinate system, uh, let's see, there we go. And we, for instance, specify that this point in our world coordinate system is the origin, which has the coordinates 0, 0, 0. We have to transform this whole thing into a 2D space. Uh, let's see. Uh, let's see. Yeah, I'm just checking out the stream settings here. Hopefully everything is fine. I'm wondering. Yeah. Okay. It seems like it's dynamically updated. Anyway, so if we want to uh, transform a 3D space into a 2D space, for instance, if that is the origin of a whoops, Oh my god. I'm really not that great at using paint. I'm sorry. Anyway, if we have a screen, space, we need to do transformations so that whatever we render in our world space gets transformed into a screen space. Usually you define a camera that has the same coordinate system. I somehow got a dot here. And let's say that this is our camera. Which has its own local coordinates of 0.0.0. We need to be able to transform whatever we look at in our world into a local camera space. And after that, we need to, let's see, if we do something like this, and no, we do not have a fill, we want a fill of the solid color. We need to, from that three-dimensional space, create a camera that gets a clip space which can be used to transform our let me just look at the bitrate. Yeah, so first we transform from world space into a local camera space in three-dimensional space, and then we use a clipping um, method to translate uh, um, 3D space, whatever is in between the near plane, as it's called, and the far plane in 3D space gets transformed into a 2D space with a sense of depth. Yeah, so the transform we use, or rather the transformation that, let's see, okay, so we have to do this one, is the view matrix, and this is the, let's see here, this is a projection matrix, which our renderer will apply to every single um, vertex that we pass in to our renderer, meaning that in our graphics pipeline, let's just look it up, graphics pipeline DirectX 12, meaning that whatever we pass into our input assembler gets passed into our vertex shader, which does this transformation for whatever vertex we pass in. And that information contains a um, uh, what what is it called? That information is like um, in part uh, the same information that gets passed into the vertex shader with an additional component of whatever vertex got processed and its clip space coordinates. So if we look into our shaders here, um, for instance, the SV position uh, usually, or is it something else? Let me just see. Is the semantic for it something else? Uh, it probably is. Let's see. No, we use the SV position as as our clip space position. So in homogeneous clip space, as it's called, um, uh, or rather, let me rephrase that. So during this shader here, everything gets multiplied by the view projection matrix, which is the product um, of these two matrices uh, is man, I hate this headset. It keeps on disconnecting for some odd reason. Uh, it only does it whenever I use the microphone. Uh, this probably won't fix anything, but at least it will be faster to turn off on whenever it decides to shut down. Oh, anyway. So yeah, you multiply these matrices and get a combined view projection matrix, and um, you store that in your pipeline through a constant buffer, which we looked into last time as part of the what we call the pass data, which is like for every render pass or pass through the pipeline, we have different information, and we will store our virtual camera position and its view projection matrix. Uh, and we will do a multiplication of the world position of our vertex to by the view projection matrix to get its position in the um, clip homogeneous clip space. Yeah. So the shader language HLSL has a lot of structures and methods for handling that. On our CPU side, we do not have anything of the like. We can use different libraries. Um, a popular one is the GL math library. A popular one to use with DirectX is the DirectX math library. Uh, I usually use the DirectX math library. Um, But there is a problem with the DirectX math library, which is the ordering of the data structures in memory are kind of not the same as the shader language. It's also not the same as the other shader languages because you can, as far as I understood, save a CPU or GPU cycle if you order things in memory uh, um, in a column major way. Uh, yeah, it would also mean that we weren't uh, forced to do weird transposes. So yeah. Uh, let's see. I'm just messing around with the stream. Okay. Yeah. So um, that's a lot of blabbering. Um, the view matrix is also where we kind of define our coordinate system, since everything gets translated by it. Um, there's a really good book on DirectX 12 programming by Frank, can't remember his name, which explains a lot of the math behind it. Um, yeah, so we will be using some of that math. Um, luckily, I do know the general principles of different math operations with vectors and matrices. At least I have some knowledge from the machine learning series I have on YouTube. So hopefully it will not be too daunting. Yeah, but I'm gonna segment this on YouTube as a short introduction.